Welcome to the fourth lecture. Today we will discuss some numerical examples from whatever we have discussed in this week so far. So, the first numerical question is, find the coefficients of thermal expansion for a unidirectional glass epoxy lamina of the following properties, and we have to find this out in the principal material direction. So, we need alpha 1, alpha 2. So, we know the formula for alpha 1. So, alpha 1 is alpha f multiplied by Vf into Ef plus alpha m multiplied by Vm into Em divided by Vf into Ef plus Vm into Em. So, here in this example the properties of the fibers are also isotropic. So, alpha m here alpha f here is equal to 4.5 into 10 to the power minus 6, and then we have Vf, Vf is equal to 0.6, and then we have Ef, Ef is equal to 70 GPa plus we have alpha m is equal to 90 into 10 to the power minus 6, and then we have Vm, capital Vm, which is 0.4, because we know that Vm plus Vf plus Vm is equal to 1. So, this gives me that Vm is equal to 0.4, and then we have Em, Em is 4 GPa. In the denominator we have Vf is equal to 0.6 and Ef is equal to 70 GPa and Vm is equal to 0.4 and Em is equal to 4 GPa. So, finally, the value that we get is 7.638 into 10 to the power minus 6 per degree centigrade. Now, we will find out alpha 2. For alpha 2 it is it is E, it is alpha f multiplied by Vf into 1 plus alpha f multiplied Vf into 1 plus nu f plus we have alpha m into Vm into 1 minus 1 plus nu m, and then we have minus alpha 1 2 in alpha 1 into nu 1 2, nu 1 2 multiplied by alpha 1. So, alpha f we know it is 4.5 into 10 to the power minus 6, Vf is equal to 0.6 and 1 plus nu f is equal to 1, means 1 plus 0.2. Then we have alpha m is 90 into 10 to the power minus 6, Vm is equal to 0.4 and 1 plus nu m is 0.35, and then we have something called nu 1 2. So, nu 1 2 is alpha f Vf plus alpha m Vm, sorry not alpha f, nu f Vf plus nu m Vm, and if I put the values of these respective nus and the respective capital V's, finally what we get is 0.26. So, here we have 0.26, alpha 1 is whatever we have found here. So, multiplied by 7.638 into 10 to the power minus 6. Then if we do the calculations, finally the value comes out to be 49.86 into 10 to the power minus 6 per degree centigrade. So, here we were given the properties of the constituents, and from there we found out the equivalent properties. So, it was example from the micromechanics. Then we will do some example from macromechanics. So, here we have to find out these NXT, NYT and NST and MXT, MYT and MST, and also the coefficients of thermal expansion of the laminate. So, that means we have to use the theoretical discussion that we had in the last class. So, for that first we have to find out the alpha. First let us find out the Q matrix. So, this is the lamination sequence. So, for plus 45 minus 45, those are the two types of plies we have. So, we have to find the corresponding Qs for those, but before that for each ply we have to find out the Q matrix with respect to its principal material direction. So, the Q12 that we get is 142.77, and then Q11 is 142.77, Q12 is 2.86, and then Q16 is 0, then 2.86, then we have 10.36, 0, 0, 0, 7.2, and this is GPa. So, we know that Q11 is equal to E1 minus E1 by 1 minus nu1 to nu21, Q22 is equal to E2 by 1 minus nu1 to nu21, Q66 is E6, and Q12 is nu21 into Q11 or nu12 into Q12, and we also need to know nu21, and nu21 is nu1 to E2 by E1. So, with all this which we have been discussing for last quite a few classes, we can get this Q matrix with respect to the principal material direction. Now, we need to find out Q matrix with respect to XY system for the 45 degree plies. We already have the transformation relation. So, with those transformation relation, finally we can find out the Q matrix for the 45 degree plies, and the Q matrix becomes 46.91, then QXY is 32.51 and QXX is 33.10, then 32.51, QYY is same thing 46.91, and we have 33.10. Here also we have 33.10, 33.10, and QSS is 38.28, 38.28 GPa. So, this we obtain from the transformation relation in terms of m and n, where m is cosine theta, n is sin theta, with theta being the angle between the axis 1 and the axis x. So, with that same transformation relation, the Q matrix for minus 45 degree comes to be, we know that when just the theta changes its sign, everything remains same, only these two quantities they changes their sign. So, the new quantity will become 46.91, 32.51 minus 33.10. Here we would have 32.51, 46.91 minus 33.10 minus 33.10, and here we would have 38.28 GPa. So, now we have to find out the thermal forces. So, before that we need to find out alpha x, alpha y and alpha s. So, alpha x, alpha y and alpha s for 45 degree ply. So, a degree that we know the relationship is m square alpha 1 plus n square alpha 2 n square alpha 1 plus m square alpha 2, and here we would have 2 mn alpha 1 minus alpha 2, and then the relationship the values that we get is 13.05 and minus 227.9 into 10 to the power minus 6 per degree centigrade, and then accordingly we can find out alpha x, the free thermal strain alpha x into delta T. Delta T is given to us, that is 56 degree centigrade. So, alpha x into delta T, alpha y into delta T, alpha s into delta T, that is also for the 45 degree ply, and the values come to be 730.8, 730.8 and minus 1562.4 into 10 to the power minus 6. Now, for the minus 45 degree ply, we have alpha x, alpha y, alpha s for the minus 45 degree ply, m square alpha 1 plus n square alpha 2, n square alpha 1 plus m square alpha 2, here we have 2 mn alpha 1 minus alpha 2, and then what we get here is 13.05 again 13.05 and 27.9 into 10 to the power minus 6 per degree centigrade, and accordingly we get alpha x, alpha y, alpha s into delta T for minus 45 days 45 ply is 730.8, 730.8, this is plus not minus, 1562.4 into 10 to the power minus 6. So, here m is equal to cosine 45 degree, n is equal to sine 45 degree, here m is equal to cosine 45 degree because n is equal to minus sine 45 degree, because if we know that cosine of minus theta is equal to cosine theta. Now that we have found out these free thermal strains, now we can find out the Q matrix, sorry not the Q matrix, I mean the thermal forces and moments. So, that becomes, we know that it is k equal to 1 to n Q matrix in the xy system, and then we multiply that with alpha x delta t, alpha y delta t, alpha s delta t for the kth ply, and then we integrate and sum it up. So, if I do that, here what we get here is 2 multiplied by Q matrix for the 45 degree ply in the xy system multiplied by, we have alpha x for the 45 degree system is this 730, not alpha x, I mean this free thermal strength. So, 730.8 minus 1562.4 into 10 to the power minus 6, and we also have and for the minus 45 degree ply Q matrix in the xy system, and it is multiplied by the corresponding vector of the free thermal strengths 730.8, 1562.8, and then this entire quantity is multiplied by the thickness of each ply. So, thickness of each ply, so this entire thing is multiplied by T. T is thickness of each ply, which is here 0.2 millimeter. After all these things, the value that we get is 0.0464, 0.0464 GPa millimeter. Now, we can find out the thermal moments mxt, myt and mst, and it can be seen that this will come to be 0. So, when the laminate is symmetric, there is no thermal moment induced, provided that each ply has the same increase in temperature or moisture. Now, our goal is to find out the CTE for the laminate, and the procedure that we discussed is that for CTE of laminate, to find that out, the procedure involves delta T is equal to 1 degree centigrade. So, previously the delta T was 56 degree centigrade. So, in all this analysis our delta T was 56 degree centigrade as given in the question here. Now, to find out the CTE of laminate, we use delta T of 1 degree centigrade. So, in that case NXT, NYT and NST becomes whatever you found out before for 56 degree centigrade, we just divide that by 56 and that gives us the NX, NY, NST corresponding to unit rise in temperature. So, it becomes 0.000, 829, 0.000, 829, 0 GPa millimeter, and A matrix is 2 into thickness of each ply multiplied by Q matrix for the 45 degree ply plus Q matrix for the minus 45 degree ply, both with respect to the XY system, and that gives me A matrix as 37.528, 26.0008, 0, 26.0008, 36.528, 0, 0, 0, 30.624 GPa. Now, it is symmetric matrix, symmetric laminate. So, B matrix is 0. So, that tells me that A matrix is just inverse of small a matrix is just inverse of capital A matrix, and then if we write the formula alpha x bar, alpha y bar, alpha s bar is equal to small a matrix multiplied by nxt, nyt NST again for unit temperature rise, this one. Then finally, alpha x bar, alpha 2, alpha y bar and alpha s bar are found out to be this 1.3041, 1.30410 and everything is multiplied with 10 to the power minus 5 per degree centigrade. So, with these numerical examples I would like to conclude this lecture here. These numerical values can be found in the book by M. Mukhopadhyay. So, let us end this lecture here. Thank you.